Welcome to the deep dive. We sift through the sources so you don't have to, getting you right up to speed. Today, our mission is, well, pretty cool. Imagine solar panels that don't just, quit when the sun goes down or it gets cloudy, but panels that actually make electricity from the rain itself. We're looking at rain-powered solar panels today and what they could mean, especially for a city like Baltimore with its, well, changeable weather.
That's right. It's really about tackling that big limitation of solar, making it work in all weather conditions. So we'll get into the tech, the costs, the efficiency, and how it fits or might fit with Baltimore's climate based on the sources we've got.
Okay, so let's dig into this a bit. How does this actually work? Getting power from rain sounds almost like science fiction.
It really does, doesn't it?
Yeah.
Essentially, it comes down to a very thin layer of graphene on the panel's surface. See, rainwater isn't just pure water. It has tiny charged particles, ions. When those raindrops hit the graphene, there's a sort of friction, an interaction. And that impact, the kinetic energy, gets captured by something called a triboelectric nanogenerator, or TANG for short.
Pang. Right?
Yeah, it basically turns that physical motion, the raindrop hitting, into electricity. And the really clever part is they also work just like normal solar panels when the sun is out. So photovoltaic cells are still there.
Ah, so it's a genuine two-for-one deal. All weather.
Exactly.
That dual function sounds great. But let's talk reality check. You mentioned efficiency. 6.53% under simulated sun. That sounds, well, not very high compared to standard panels hitting maybe 20% efficiency. Is this practical yet?
That is the key question, isn't it? That 6.53% figure does highlight that, yes, it's much less efficient than conventional solar right now. It tells us the technology is, still very much in development, getting it ready for large-scale use. That's still a pretty big hurdle.
A hurdle, yeah. Okay.
Yeah, so it's not really about replacing traditional solar yet. Think of it more as a potential add-on, a complementary tech.
Right, complementary. And I guess cutting edge usually means expensive. What's the story on cost? Especially thinking about Baltimore homeowners.
Well, specific pricing for these rain panels isn't really set yet. They're too early stage. But given the advanced stuff like graphene and the fact they do two jobs, yeah, the expectation is the initial cost will probably be higher.
Higher than traditional solar.
Likely, yes.
Mm.
For context, installing traditional solar in Baltimore averages around $2.99 per watt. So a typical 5-kilowatt system might be about, say, $14,950, somewhere around there.
Before any incentives, though.
Oh, absolutely. Before incentives. And there are ways to bring that cost down.
Like the federal tax credit.
Exactly, the 30% federal one. And Baltimore County also has property tax credits for solar. Those help a lot with the standard systems.
So presumably, if these rain panels take off, we might see similar incentives down the line.
You'd certainly hope so, yeah, to encourage adoption.
Okay, let's connect this back to Baltimore specifically.
Yeah.
We get our fair share of rainy days, maybe 113 a year.
Roughly.
So does that actually make Baltimore a good test case for this kind of thing?
It really could. I mean, think about it. Traditional solar output drops significantly on those cloudy, rainy days.
Right.
These panels could potentially fill that gap, generating some power precisely because it's raining. It smooths out the generation curve. Plus, with regional concerns about stronger storms, hurricanes, maybe related to rising sea temperatures, having a power source that isn't completely knocked out by bad weather, that adds resilience.
That resilience point is interesting. We already see big solar projects in Maryland, like the Blue Crab Solar and Storage one.
Down in Dorchester County.
Yeah, 100 megawatts, big battery, powering thousands of homes, bringing in revenue. They use the traditional panels, right?
Correct. Conventional solar technology.
But you can imagine maybe integrating this rain power tech into future projects like that to boost reliability when the weather turns.
That's exactly the potential. It could enhance the system's overall performance, especially during storms or long cloudy periods, making the power supply even more dependable.
Okay, so boiling it all down, what's the takeaway?
Well, the benefits are pretty clear. You get power in sun and rain, which is great for places like Baltimore, and it helps move away from fossil fuels year-round.
Like the downsides.
The challenges are real, too. Likely higher initial cost. The efficiency isn't there yet compared to standard solar, and we just haven't seen it deployed on a large scale. So like I said, it's not a replacement right now. It's a really promising complementary technology, something that could make our future energy grid stronger, more reliable.
Right, making the grid stronger. So, final thought here. As we push for more sustainable energy, maybe the big breakthrough isn't just focusing on the sun alone. What if it's about cleverly combining nature's forces, sun, rain, maybe other things too, to power our lives. What could that mean for energy resilience right here in your community?
Definitely something to think about next time you hear the rain coming down.